Guys, in this video we are going to see how to do polynomial fittings using C++ programming, and here I have the code for that one already, and let's look at this code one by one. First we set the precision. It's going to give the output, the final output for correct for 4 decimal places, and then here we ask the user to enter the number of data pairs to be entered in, and after the user enter the value, for example if it's 4, that's going to be a capital N, and we are going to have capital N number of x values, and also we are going to have capital N number of y values, and then we ask the user to enter the x-axis values, and then that's going to be x inputs, and then we ask the user to enter the y values, and that's going to be here, and then we ask the user to enter the degree of polynomial. For example, if it's second degree polynomial, it's going to be just 2, and that's going to be of a small n. And after that we have this equation. This is for this one, like if you set the polynomial equation in matrix form in Gaussian elimination pattern, it's going to look like this, right? You are going to have a matrix pattern like this, and you are going to have coefficient, and in the right hand side we are going to have one column like this. Okay, so that is the equation. This is to calculate this sigma xi square and all these things, right? So it's calculating all these things, and here we have this equation right here to calculate all these values, and that's why we included this C math. It will do all these calculations, right? And after that we have this one, this b times n plus, actually b array n plus 1 n plus 2, and this is basically, the first one is representing the rows and second one is representing the column. If you notice, the rows are n plus 1, columns are n plus 2. That is because if you look at this one, let's make it smaller, and here if you look at this equation right here, here we have n plus 1 number of rows and n plus 1 number of columns, because if we are starting in C++, we always start from 0. So if you start from 0 and go until n, you're going to have n plus 1, right? Because we are having n and including 0, that's going to be n plus 1. So that's why we have n plus 1 rows and n plus 1 columns. But if you note here, you have seen that here we have n plus 2 columns. That is because if you look at the right hand side, we have one more extra column. In augmented matrix pattern, it's elimination matrix pattern, we are going to have one more in the other side, right? So that's why we include one more, that's n plus 2. After that we included the coefficient, that's this a value, right? And that is it. After that it's all about this matrix calculations. So you have to know about matrix like elimination, Gauss elimination methods, and those are those equations, right? Now let's look at an example and see whether this one works. I include this code in my below section, so you can click the link and see the codes. And let's look at an example. Here we have two set of data. Now let's try this one. Okay, so here we have 5 set of data. I'm going to run this code and see what we get. Okay, here it's asking enter the number of data to be entered in. So here we have 5 data. I'm going to put 5 right here, and enter the x values. X values are 0, 1, 2, 3, 4. I'm going to put that one right here, 0, 1, 2, 3, 4, and enter. Enter the y values, 1, 1.8, 1.3, 2.5, 6.3, 1, 1.8, 1.3, then 2.5, 6.3, 2.5, 6.3, and that is it, right? That is it. And this is asking what degree of polynomial do you want to use for the fit. Let's put second degree polynomial, so 2. And if you notice, we are getting this one, this equation. The fitted polynomial equation is given by this one, right? Now let's make sure whether this one is correct. To make sure that one is correct, we can check this one through our Excel file. So let's select this one, go to insert and go to this graph right here and click these points and then add trend line. Okay, so here we have this polynomial and second degree and display equation on the chart, and this is the equation we are getting for the polynomial fit. Now let's go ahead and verify whether this is correct. Okay. Oh. Okay, so this is the equation we have. Now let's compare this one with this one. And okay, where did it go? Okay, here we go. Here we have 0.55 x squared, 0.55 x squared, negative 0.107 x power 1, negative 1.07 x, 1.42, and x power 0 is basically 1, so that's why we have just 1.42. And this is correct. Now let's look at the second set of data. Now let's try that one. So I'm going to run this again. Okay, enter the number of data pairs to be entered, and here we have number of 5 data pairs, so I'm going to enter 5, and then x values, it's going from 0 to 4, so 0, 1, 2, 3, 4, and then after that it's asking enter the y values. It's going 0, 1, 0, 1, and then 8.005, 8.005. After that we have 26.906, 26.906, and after that we have 63.98606, 63.9806. And if you look at this one, it's almost look like a third degree polynomial because we are having 0, 1, and 8. Let's try 3 right here and see what we get. 3 and oh, something wrong here. Let's see what's the mistake. Three degree polynomial 0, 1, 2, 3, 4. We entered 0, 1, 8.005, 26.906, 63.9806. Okay. You know what? Let's try this one again and see what we get. Run this one again. 5. And here we have 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. And the next one is y values. It's going to be 0, 1, 0, 1, 8.005, 8.005, and then we have 26.906, 26.906, and then we have 63.9806, 63.9806. Now let's enter this one. Let's put 3. Okay, it's not working. It's not working. Let's try some different, like maybe, you know, some different values. I have to figure it out what's wrong here. X values, like let's put 1, 2, 0, 1, 2, 3, 4. Okay, 5 0 1 2 3 4, and let's just put the first values alone: 1 8 26 63 or 64, 1 8 it's lagging right here. Let me try one more time. 0 1 2 3 4, and here we have 0 1 8 26 63, 0 1 8 26 63, 8 26 63, and let's try this one. Let's try 3. Oh my god, it's not working. Okay, maybe we should try for 2 and see what happens. 5 0 1 2 3 4, and let's try the same data. 0 1 8 26 63, 0 1 8 26 63. Let's put 2. Okay, it's working for the second degree, but there's something wrong with third degree. I have to figure it out. Okay, now yeah, you can try with your software and see whether it works. You know, sometimes these online things doesn't work very well. Okay, now to make sure this one, we can enter the same data here and verify this one, right? So 0 1 2 3 4, and 0 1, this is 8 26, and then 63. Let's try this one. I go to the insert and then go to this graph right here, and Trendline Polynomial, and here we have to display the equation. Okay, so you can see that here we are getting the same thing, right? Make this one bigger so you can see. So you can compare this one with this. So here we have 5.9286x squared, same thing, negative 8.6143x power 1, and then here we have 1.2571, and that's how we do the polynomial fitting using C++ programming. I hope this helps. Thanks for watching.